We are going to be solving systems of inequalities using the graphing technique, okay? So you will draw graphs of your inequalities. You will look to see where they intersect, and then you will shade in the appropriate region that satisfies your inequalities system, okay? So the first thing we need to do is figure out how to graph these things. Let's pretend instead of inequalities, we just have equations. And so if I have the equation 4x minus 5y is equal to 0, what would that graph look like? Well, you might recognize that as a linear function because none of my variables are squared or square rooted or anything weird. It's just straight x and y. And so if that's linear, I like to have my linear equations in the form y equals mx plus b. I'm going to jot that down here. Y equals mx plus b. I like my linear equations to have that general form where that y is all by itself, because then I can see the place where it crosses the y-axis, the y-intercept, and I can see what my slope is, right? My slope is rise over run, and then I can plot points from there. Okay, so we're going to get the y variable by itself here. So that's going to look like 5y equals 4x, or y is equal to 4/5 x. Now there is no constant. There is no plus b. And so that means this graph crosses through the origin. Let's put a point there at the origin. And the slope is 4/5. And so from that origin point, I'm going to go up 4, 1, 2, 3, 4, to the right 5, 1, 2, 3, 4, 5, and put a point there and connect those 2 points with a solid line. And there's your graph of the first equation. The first equation. Now, technically, it's an inequality. So the solution is not going to be the points on that line right now. It's going to be in a whole region of points. Here's what we need to do before we go to that second inequality. Go back up to the first inequality and notice that it's a less than or equal to 0 right here, less than or equal to 0. All right, so we need to decide if the solution to that inequality is all of the points on top of that line or all of the points below that line, okay? And so the way we're going to figure that out is we're going to choose a point to test. Whoa, I lost my entire line. This is becoming quite the mess, isn't it? Okay, we want to choose a point to test to decide if our solution set should be above the line or below the line. So I'm going to choose the point, I don't know, how about 0, 2? The point 0, 2 is right there. Now, the ordered pair 0, 2 is what I'm talking about. Now substitute the ordered pair 0, 2, 0 for x and 2 for y up in that inequality. 4 times 0 minus 5 times 2 is less than or equal to 0. If that comes out to be true, then you want that point to be included in your solution. Is it true or is it false? Well, 4 times 0 is 0. Minus 10 is negative 10 less than or equal to 0. Yes, that is true. Therefore, the point that I've chosen to check needs to be part of my solution set, and that was above the line. So I want to shade in everything above this line as my solution to my top inequality, okay? So far, I've got everything, all the points in the Cartesian plane above this line. Makes sense. Now I have to look at the bottom inequality. If I were to write that with an equal sign, I'm only doing this to see what the graph looks like. This is a linear equation. I get y is equal to 2x minus 2 when I get that y variable by itself. So in this case, my y-intercept is at negative 2. Put a point down there. And then my slope is positive 2, so you go up 2 and to the right 1, and you put a point there. And I'm going to do it again. Up 2 over 1, up 2 over 1. Get a few points here, this way. Gives you an idea of what this line is going to look like. So I'm going to connect those points with a solid line as well. Okay, so now you got to decide, well, on that second line, do I really want all of the ordered pairs above it or below it and to the right? And you're going to do the same process. You're going to choose a test point. We can use the same exact test point if we want. 0, 2, plug the value 0 in for x and 2 in for y, and tell me if it comes out true or false. And so in that case, you're going to have 2 times 0 minus 2 for y is greater than or equal to 2. We have to decide if that's true or if it's false. Now here we get 0 minus 2 is negative 2. Is negative 2 greater than or equal to 2? And that is a false statement. Therefore, the test point 0, 2 is not to be included as part of that solution. So for that second line, I want to treat everything below that line as my solution. Okay, see what's going on here? Don't want to include the test point. It didn't work on that particular inequality, so don't use that. Don't include it. So shade the opposite side. Now the actual solution, the region of ordered pairs that make both inequalities true, where are they both true? Well, they are both true inside here. That is where both of the inequalities came out true, and that is the overall region that satisfies this solution, this system of inequalities. Now I've said to use solid lines in both of these graphs, and there is a reason why solid lines are needed as opposed to a dotted line. A dotted line or a dashed line is only going to be used in the case of strict less than or strict greater than without that equal sign underneath. If that is what you have in your inequalities, you want to use, they call it a dashed line. Okay, so play around with the MyLabs Plus homework over the next few days before your test, just so that you've got a good feel for how to use the graphing technology on the computer. It takes a bit of practice before it becomes natural.